Welcome back. Today we are going to talk about absolute value equations and inequalities. So let's get started. So we have lesson 1.3, which is absolute value equations and inequalities. You are going to solve each equation and you are always going to check your answers. Okay. Now that doesn't necessarily have to be a physical writing of checking your answers, but you should be mentally checking or using your calculator to check. So number 1, the absolute value of negative 4x equals 32. Well, let's talk about absolute value real quick. So hopefully you all know what absolute value is, but if not, it is the distance from 0, okay? So for example, distance from 0, let's say, what is a number that is 4 numbers away from 0? Well, you have 4 and you have negative 4. So you end up having 2 answers. So that thought process is going to need to stick with you when you're doing absolute value problems, meaning you should always have 2 answers that you are checking. Won't necessarily mean you always have 2 answers that work, but you should always start with 2 answers or 2 methods for finding it. So first one is that you're going to treat the equation as is, just without the absolute value sign. So you have negative 4x equals 32. Okay. Or you keep the inside from the absolute value the same, and you set it equal to the opposite of the outside value. So negative 32. Okay. Again, this stays the same, and the answer is the only thing that becomes the opposite. So we go ahead and solve. X equals negative 8. And if I divide by negative 4 here, I get x equals 8. So my answer is that x equals negative 8 and x equals 8. Now, do those actually work? Let's verify. So if I substitute negative 8 back in, negative 4 times negative 8 is 32. The absolute value of 32 is 32. So that one does work. Let's try 8. 8 times negative 4 is negative 32, but the absolute value of negative 32 is 32. So that one works as well. Let's try the next one. 2 times the absolute value of 3x minus 2, absolute value equals 14. Okay. Now it is important to note that anything that's outside the absolute value should never be distributed when you are in the method of solving for the variable. Okay, when you're checking, you can do that, but when you're solving for the variable, you cannot distribute. So in order to solve, I would not distribute the 2, but I can divide, caught my pencil, I can divide by 2. Now when I divide by 2, that only simplifies that part, and I have the absolute value of 3x minus 2 equals 7. Now that the absolute value is isolated, now I can treat it as 2 separate equations to solve. So I have 3x minus 2 equals 7, or 3x minus 2 equals negative 7. Okay, and again, the absolute value part is the same, the answer is the opposite. So go ahead and solve, add 2, and divide by 3, I get x equals 3. Add 2, divide by 3, I get x equals negative 5/3. Okay, much different than the last one where they ended up being the same value but opposites. Okay, let's verify that they work. 3 times 3 is 9. 9 minus 2 is 7. Absolute value of 7 is 7. That one works. Let's try negative 5/3. Now you're thinking, I gotta use a calculator for this, but you don't. You don't. 3 times negative 5/3. What's gonna happen? The 3's cancel, so you get negative 5. -5 minus 2 is -7. Absolute value of -7 is 7. So it does, in fact, work. Let's go ahead and try number 3. Absolute value of 2x minus 3 equals -1. Now I'm going to challenge you to go ahead and pause this and try it on your own, and I'll check back with you at the answer. Make sure you pause it and you try it. Did you pause it? Good. Let's talk about it. So 2x minus 3 equals -1, or 2x minus 3 equals 1. Okay, now you're not required to show the adding and the subtracting or the dividing. I've just been doing that until you get more comfortable with it. So I'm going to go ahead and skip forward and not write it every time. I'm going to add 3. Adding 3 to -1 is a value of 2. So I get 2x equals 2. I'm going to divide by 2 on both sides, and I get x equals, 3 lines, x equals 1. Okay? And I'm going to add 3. 1 plus 3 is 4. Divide by 2, and x equals 2. Now, if you need to write everything, that's perfectly fine, and that's perfectly okay. But I'm just going to go ahead and skip forward and not write every single step, just so we can save some time. Now we got to check. 2 times 1 is 2. 2 minus 3 is -1. Absolute value of -1 is 1. Well, does 1 equal -1? No, so that one doesn't work. Okay, let's move on to the other one. 2. 2 times 2 is 4. 4 minus 3 is 1. Absolute value of 1 is 1. That doesn't equal -1 either. So what does that mean if both of them don't work? Well, it means that you have no solution. A better question is, could I have known that this was no solution without having to do all that work? Yes. Okay. What could I have seen from the very beginning? Is this right here. Can absolute value ever equal -1 to begin with? Is there ever going to be a distance from 0 that's negative? No. So I could have known that right from the beginning. So next time, remember that. Okay, number 4. Three times the absolute value of 4w minus 1, absolute value, minus 5 equals 10. Okay, I'm going to go ahead, oh, my apologies, you can't see that. I'm going to go ahead and get you started, and then I'm going to let you try and solve the rest. So first thing, similar to number 2, we have to get rid of things that are outside of the absolute value. So the first thing would be what? Think of it as a variable. Let's say it says 3x minus 5. What would you do first to solve? Well, you would add the 5. So you get 3 times the absolute value of 4w minus 1 equals 15. And then I would divide by 3, and I get the absolute value of 4w minus 1 equals 5. Now that it's isolated, I can go ahead and tune my 2 equations. Okay, go ahead and pause and do that. I hope you're pausing. Okay, because who wouldn't want to check and see if they actually got it right? Okay, greatest way to directly figure out if you're doing something right or wrong is trying it and learning from it. Right? You won't learn if you don't try. Okay, let's see what happens. So if I add 1 to both sides, I get 6. If I divide by 4, w equals 3 halves. If I add 1 to both sides, I get -4. Divide by 4, I get w equals -1. Okay. Now, go ahead and check and see if these work. Okay, and again, this can be done mentally, or you can use your calculator to verify that it works. Okay, and all that would take is I can say 4 times 3 halves, which is minus 1, which is 5. And that's correct. Absolute value of 5 is 5, so 3 halves does in fact work. Now let's try negative 1. Okay. Another fun trick on your calculator is if you hit second and enter, it rewrites exactly what you just said. So I can go over and type what I want. And I want negative 1, but I don't need that extra 2, so I can just hit the delete button. Okay, and I get negative 5. But remember, that's within absolute value. So what's the absolute value of negative 5? It's 5. So that works. Okay. Now there is an absolute value button on your calculator. You just go to math, okay, and go over to number, and there's ABS, which stands for absolute value. Okay, but in reality, you don't really need that button because it's always going to be the distance from 0, okay, or the positive value. Number 5, 1/4 times the absolute value of 4x plus 7, absolute value, equals 8x plus 16. Okay, a little bit more of a doozy on this one. So rather than dividing by a 4th, we're going to multiply everything by 4. Okay, or multiply both sides by 4. So I get the absolute value of 4x plus 7 equals 32x plus 64. And now that it's isolated, I can do my 2 separate problems. Okay, and I'm running out of a little bit of room, so I'm not going to be able to do the same way I did before, because I kind of wrote really big over here. Oh well. So I'm going to subtract 7 equals 28x plus 64. Subtract the 64, I get negative 57 equals 28x. So therefore x equals negative 57 divided by 28. That's definitely one I'm going to check in the calculator. Okay, and then my other one, which I'm going to have to squeeze a little bit. I'm just going to draw a line because I'm going to have to squeeze it, is going to be I don't want to squeeze it. I should have. Oh, this happens all the time. My apologies. So 4x plus 7 equals negative of all terms. There's multiple terms. So 32x plus 64. I know I'm squeezing that. I apologize. Okay. So therefore, the negative is distributed. So I get 4x plus 7 equals negative 32x minus 64. Okay, so when you have 2 terms, you're going to distribute it to both terms. So I'm going to add the 32x over, get 36x plus 7 equals negative 64. Subtract the 7, 36x equals negative 71. And divide, and I get negative 71 divided by 36. Okay. Now, we need to go back in the calculator and see if that actually works. So go ahead and check in your calculator and see if they both work, one work, or none work. Okay, go ahead and pause and do that. And I'm gonna show you along how you can type that all in. So this time we're going to go ahead and use the absolute value symbol. So I'm going to go to Math, Numerator, and click Absolute Value. Okay, now my calculator automatically makes the little lines, but yours might still say ABS and then parentheses. So we have 4 times negative 57 divided by 80, or 28, plus 7. And that's okay that it's a decimal. You can leave it like that for now, because we're just comparing if they equal each other. And then on the other side, we have 32 times negative 57 divided by 28, plus 64. And as you can see, those do not equal each other, so therefore that one does not work. Now I'm going to go ahead and do the same thing with negative 71 divided by 36. Okay, now remember that trick that I taught you? Okay, second enter, and it retypes it. And then I can just simply write over what I want to write over. Makes it a little bit easier, but not necessary. Okay, this time I get a little bit easier of a decimal. Now I won't be able to rewrite the original, so I'm just going to go back and do it again. So Math, number, numerical, absolute value, 4 times negative 71 divided by 36, plus 7. And looky there, those both equal the same thing. So therefore, even though that's a crazy fraction, it works. Okay, and that is part 1 of this lesson. Join me in the next video for the last part.